Okay, year 9 is some help with your mathswatch homework, just in case you get stuck. Right, so look at this question here. A circle has diameter 11 centimetres and a square has length 7. Use Pythagoras Theorem to show that the square will fit inside a circle without touching the edge of the circle. Well, that's quite straightforward. We see that's a square, all lengths will be 7, so we need, that will make a right angle triangle there. So I'm using a squared plus b squared equals c squared for the square. We have 7 squared plus 7 squared equals c squared. That's going to be 49 plus 49 equals c squared, because we're finding the longest side. That's got to be 98 equals c squared. So we square root both sides. So c equals square root of 98. And just going to do that on a calculator. That's 9.9 centimetres to 1 decimal place. So if this section is only 9.9 centimetres and the diameter is 11, then that square will fit easily, because the diameter is longer of the circle, which is 11, is longer than this. So you can say 9.9 centimetres less than 11 centimetres. So we'll fit in a circle. So we'll fit. Right, this one, just a bit of problem solving. This will probably appear non-calculator test, because you can work this out with a calculator. So you've got a rectangular gate made using 6 straight pieces of steel. That's 1 piece, 2, 3, 4 and 5 and 6. The weight of the steel is 2.5 kilometers per metre. So we've got 5 here, 5 here and 12 there. So far, let's just add those together. That makes 10, add 24. So we've got 34 metres of steel so far. Now we're missing this diagonal length here. On this side and on that side. It is a rectangle, so we can use Pythagoras Theorem, the right angle here. And we're finding the longer side, the hypotenuse. So again, we have a squared plus b squared equals c squared. So that's 5 squared if I call that a and that b, plus 12 squared equals c squared. Now 5 squared plus 12 squared, that's 25, add 144. So 169 equals c squared, and if you square root both sides, you know that 13 equals c, and that would be in metres. Now that would get you some method marks in the exam. Adding this will probably get you some method marks in the exam. But how many of these diagonal steel beams have we got? We've got 2, so let's double that. 13 times 2 equals 26 metres. Now we've got the 34 metres on the outside, so we add them together. 24 add, 26 add 34 equals 60 metres. Each metre weighs 2.5 kilos, so then we would do 60 times 2.5, which is 2 times 60 is 120. Add a half of 60 is 30, so it equals 150 kg, and that will be your answers, marks. There'll be a method here. That's a 3-mark question. So no, you normally do need a C1, I call it a communication mark or a comprehension mark. You do normally need to make a statement for these types of questions. Now we've done something similar on another video to this question. Now it has a perimeter of 22. So let's draw a triangle here. We don't know if it's right angle, but let's try to assume it is 22. Let's call this ABC. Doesn't matter how you do it. AB is 8 centimeters. BC is 5 centimeters. We can't have BC here because that's the longest side. So let's change that to this. So BC is 5 centimeters. The perimeter is 22. The perimeter is the outside of the shape, so we have to do 22 minus 8 add 5, which is minus 13, equals 9 centimeters. So we're assuming that's 9. If that's the case. Deduce whether it's a right angled triangle. Well, it's a right angled triangle if trigonometry or Pythagoras Theorem work on it, because it only works for right angled triangles. So that means we need to prove that a squared, let's write that down here, a squared plus b squared equals c squared. So that's, doesn't matter what you call a and b, but c is the longest side. So we have 5 squared plus 8 squared. Does that equal 9 squared? That's 25 plus 64 equals 81. Now 25 add 64 is actually 89. 89 does not equal 81, so therefore not a right angled triangle. Your method marks for this type of question likely to be M1 here, M2 here, and that would be your A1/C1 mark. And I hope that really helps you all with your maths watch homework. Thank you.